In this video 4.6, we're going to be looking at scale models and maps. By the end of the video and work time in class, you should be able to say, I can solve proportions with scale. For some vocabulary here, scale model is a model similar to the actual object it represents. Scale is a ratio of the length of the model to the matching length of the actual object. So when we're looking at scale models, we have a little like miniature of some actual object. And scale models, you might see like a little figurine, like collectibles sometimes look like real things to actual objects. Let's say I had a little figurine of a lighthouse. That might look like an actual lighthouse, the real thing. Or if we see a little like figurine of the Eiffel Tower that you could put in the palm of your hand, it will look like the actual Eiffel Tower that you can see in France. Looks like the real thing because they're made in proportion. And they need a scale in order to do that. And that scale compares the model to the actual object. On a blueprint we know is a drawing in the planning phases that architectures use before they actually construct a building or maybe just redesign a certain room of some sort. And it says up here on a blueprint, the cellar is 4 inches by 3 inches. So that's actually what we see on the paper in front of us on the blueprint. The scale is 1/2 of an inch on that blueprint is actually 8 feet when this room, this cellar in particular, is constructed. What are the length and the width of the actual cellar? So that scale is what we need. We have 1/2 of an inch is to 8 feet. And we are going to figure out what the length of the actual cellar is, and then we have to figure out the width of the actual cellar. And so we are going to use the scale 2 times in order to set up a proportion. So what we have here, 1/2 of an inch represents the drawing, 8 feet represents the actual room. So on the drawing, it's 4 inches on the drawing for the cellar. We want to know actually how many feet that's going to be. And then we know the other dimension is 3 inches on the blueprint, and we want to know what's the actual dimension in feet. So in these two proportions here, I went drawing to actual cellar. Drawing to actual cellar. You can see I have inches both on the top and feet both on the bottom. And so now we can solve our proportions. I know that 1/2 of 8 is 4, so I can do whatever I do on the top, I do on the bottom. 8 times 8, I get 64 feet. And then I know 1/2 of 6 is 3, and so do the same on the bottom. 8 times 6 gives us 48. So we have a 64-foot room by 48 feet. So it's 64 feet by 84 feet. That would be the actual cellar. Maps also have scales that give us a small distance that we would see on a map and compare it to an actual distance we might, like, say, drive in our car. The map distance from El Paso, Texas to Chihuahua, Mexico measures about 7.5 centimeters. So this is what the distance is on the map. The scale on this map in particular says 1 centimeter on that map is the same as 50 kilometers in, let's say, your car. So we're going from map to actual distance. We want to know what's the actual distance between El Paso, Texas and Chihuahua, Mexico. Well, we're going to use the scale. 1 centimeter is to 50 kilometers. And we are going then map to actual distance. So map, the distance is 7.5, so I'm putting this on the top, to actual distance, and this is going to be in kilometers. And so from here then we can solve our proportion. 1 times 7.5 is 7.5. So we do the same to the bottom. I'm going to multiply by 7.5, and 50 times 7.5 gives me 375 kilometers. So this right here is the distance, the actual distance between those two cities. So can you say I can solve proportions with scale? Here is your output for to work out right now in your notebook, and be prepared with any questions for the work time in class.